In this chapter, we will go over 3 examples on how to tackle some well-known weapon parts using booleans inside Blender. We will begin by tackling the classic M16A2 polymer handguard, a decently complex object to start off the modeling part of this tutorial. We start with a cylinder as the base shape and adjust the proportions a little bit. Keep in mind that since this is merely a quick example, I won't model it to the exact measurements of the original piece. Once we have the base cylinder, I like to convert its static geometry into a dynamic one by using the screw modifier. This allows us to change the number of sides of the cylinder at any point, which is very useful when using the remesh and smooth workflow. We also apply a bevel modifier above screw, which will affect all the edges with a steep enough angle. This is necessary for this workflow, as any bevels that are bigger than the smallest ones need to be modeled instead of just subdivided or smoothed. We then model the protruding parts of the cylinder, which we can obtain by scaling up our base mesh and subtracting 4 mirrored boxes from it. This method will keep all of our shapes non-destructive, which means we can go back at any point of the pipeline and modify them, which will also affect every other live shape interacting with them. To mirror objects using the scene origin as symmetry axis, I like to create an empty object, name it origin, and then just pick it anytime I need to mirror something. This way we don't have to care about the object's pivot, which is what drives the mirror modifier by default. Notice that when setting up the boolean with the cylinder, we get visible errors. Red means faces are flipped. This is because the screw modifier only turns our geometry, but doesn't weld it by default, so we go back to it and make sure merge vertices is checked. After some adjustments to the box proportions, we tackle the little rings embedded in the handguard. I would usually create them using splines, but they don't play well with the array modifier, so in this case I just use a regular circle mesh made out of edges and vertices. We can give volume to independent edges using the skin modifier, and then turn this square volume into a cylinder by applying a subdivision modifier. Then we adjust their scale using the mean radius sliders from the item panel. We then add an array modifier to quickly get the rest of these rings with an evenly spaced linear distribution. To make them smaller towards the front of the handguard, we will need to use a lattice modifier. To quickly create a lattice that is aligned to our base object, we can use the Quick Lattice button from the Interactive Tools plugin, although we can also create one by hand if needed. Notice that in this case, the lattice is very thin, because it is adapting to our base object without modifiers, which is just a string of edges. We need to properly scale it to fit our array. Be aware that lattice objects in Blender should be centered to the object by scaling them in object mode. Any transformations done in edit mode will actually deform our object. Next, we will carve out the indentation on the top and bottom of the handguard using a simple box boolean that we mirror in the z-axis. Since we need this operation to also affect previous ones, we apply both of the additive booleans first before executing the difference boolean. We notice some stepping on our big cylinder, so we go back to the screw modifier and double the amount of geometry to get rid of it. Notice that once booleans are applied, modeling is considerably slower, so make sure to delay them as much as possible. Finally, we model our last boolean, a string of cylinders cutting into the handguard's middle strip. Again, the operation will consist of a linear array, followed by a lattice. This time, we will create and adjust the lattice manually without using the Interactive Tools plugin, and then link it to the cylinder array via the lattice modifier. Finally, we deform the cylinders by modifying the lattice in edit mode, and then execute the difference boolean. At this point, we change to a red matcap material that allows us to see the volumes a bit better, and also activate the cavity display option. Our final step will be to quickly remesh and smooth our piece to create the high body. For this, we use a remesh modifier in voxel mode. Then we add a smooth corrective modifier with the following settings: factor of 1, only smooth is checked, smooth type is length weight, and finally repeat to 30. This last number is the number of smoothing iterations we apply to the object, which, along the geometry density, define how smooth the final object will be. And that's it, done.